can start. So I think we normally wait for 5 minutes. So it's 10:35. Please go ahead and good luck with your session. I'm looking forward and excited to learn from you guys.
Thanks, Kadir. So I'll start with types of machine learning algorithms, and we'll have a quick rehash of what we had done last week before we move into the exercise that was shared last week. And after we complete the exercise, we'll move to logistic regression. That is the agenda for today. So good morning, everyone, and thanks for attending this. I think as Kadir pointed out, it's last few days of moderately warm weather, and you would have preferred going out, but still thanks for taking some time off and attending this session. I'll share my screen. Let me know once you're able to see it. Are you able to see it?
Yeah.
OK, so we'll start with a little bit of theory. Types of machine learning algorithms. We'll be doing this every now and then so that the concept is conveyed. The reason we are doing it this way is like if you start with complete theory, it's not going to be very interesting. So we are trying to mix and match. So I'll start with types of machine learning algorithms. It's something which you have already seen last week, one part of it. We'll get into the theoretical details of this now. So the types of machine learning algorithms, you have broadly supervised learning and unsupervised learning. So what do these things mean? For a supervised learning, you have the data, that is, you have input and you have output. Basically what we called as dependent and independent variables. So we called dependent as Y. Some of them, some teachers of machine learning, they have different notations. They call it H theta, and they use different variables for calling them. But we have settled with Y and X. So we have dependent variables which will be Y and independent variables which will be X. We have data which has these parameters defined. So what the data conveys is there is a correct output for a set of inputs known. For example, like what we saw last time when we discussed the housing price, for a particular area of the house or the built up area of the house, we have a price. So we know that for this area, this is the price. We don't have it for all the area points, but we have for quite a few. And here we are mentioning that there is a correct output for a set of inputs. In this case, we have taken only one input. It could be multivariate also, where you have several inputs coming into play. For example, the built up area of the house, the location, the number of bedrooms, a lot of factors which might influence the output, that is the price. So we have a corrected output for a set of inputs. Based on this, what we do is we have some known relationship between input and output. What the model does is builds that relationship. It finds the relationship so that when there is something unknown coming in the form of new set of inputs, you can predict the output. So this is supervised learning. What it means is we have a set of data which would have a relationship between input and output. Based on this, we build the business logic which will relate the inputs and output so that whenever there is a new set of inputs coming in, we can get the output. Are you with me on this?
Yeah.
Yeah.
OK, fine. You look at categories as such. We have a regression, we have classifications. What is the difference between these two? So I'm introducing more statistical terms, but I'll convert it into normal terms too. So we are talking about regression being done when there is continuous output and classification when it is being done with discrete output. Say, what is the difference between these two? There are a few who might be aware of this, but for those who are not aware, I'll explain that. The output, when we say it is continuous, it is not it's not going to be single data point type of thing. What I mean by single data point is it's not going to be, say, for example, if you take the output to vary from 0 to 10, it is not going to be 0 and then 1 and then 2 and then 3 that way with no values in between. It's not going to be that way. It's going to be continuous. It can be anything between 0 to 10. Say if you are taking like decimal values also, and assume that there's single point decimal values which you take, it can vary. It can take any value from 0.1, 0.2, 0.3, 0.4 continuously till 9.9 till 10. This is what we mean by continuous output. So what is the other one? Classification is the discrete output. When you're saying discrete output, it's going to take, as the name suggests, discrete values, which means if you have a set of output like varying from 0 to 10, it's going to take values like 0, 1, 2, 3, such results. It's not going to take anything in between. 1.5 is not possible. That is what we mean by discrete output. Depending on how the output variable is, we have the categories in supervised learning, which is going to be regression and classification. What we saw last week, the linear regression will come under regression, and the classification technique, even though it is called as regression, logistic regression is a classification technique where you have the discrete output. We'll look at it later in this session. So the examples I've already spoken, the linear regression algorithm, which we saw last week. We have logistic regression, which you're going to see this week, and a more complex one, neural networks, which we'll introduce in the coming weeks. So this is a quick summary about supervised learning. So you have a set of data where you have a proper relationship between input and output. The algorithm finds the relationship so that it can find the output whenever a new set of inputs come in. Are you clear? Any questions?
No, pretty clear.
Okay,
Pretty
fine.
clear.
Sure. So now that we have seen,
just a reminder, you can also type in the questions and I'll answer them on chat if I can.
yes, yes, sir. Thanks. Okay, now we have seen supervised learning. We'll go to what is unsupervised learning. Here we have data, but there's no division as this is input and this is output. You have characteristics of data. There's no dependent or independent variables. We don't know what we are trying to achieve. If you just look at the data, what we try to do is we try to arrive at a structure based on the characteristics or variables in the data. What we mean by this is, say, if you have a set of inputs, like say you have fruits and vegetables in in uh, in a basket, and you define the characteristics of whatever is there in a basket. And what you try to do is you define the color, you define what is the size, everything you define. And what you try to do is cluster them, for example, like you cluster them broadly as fruits and vegetables. What you do in unsupervised learning is based on the characteristics, you look at means with which you can cluster them, whether you can make sense or get a structure out of the characteristics which are given. There is no input or output that is as such planned. So this is called as unsupervised learning. It need not be only clustering. It can also be something which, where you use for, demarking something. You try to split something. For example, the cocktail party algorithm. It's a famous example which is given for unsupervised learning. This is basically you have two microphones in a cocktail party, and the microphone picks all the sounds, including what people are discussing, the music in the party, everything. You get these, you get the files which will have characteristics, and what you do is you try to find find a structure in such a way that you can split between human voices and music, or between two human voices. So this is also a non-clustering example. This will also come under unsupervised learning. So examples you can look at, I already mentioned about, fruit basket or the basket analysis. We can look at market segment analysis. Companies do this. So you have a set of customers with characteristics. You try to segment them and use that segmentation to properly plan your marketing campaigns or look at what products they might be interested. Amazon does it. Your recommendation system has this as the base. So these are examples for unsupervised learning. I'll repeat. So in an unsupervised learning, the data doesn't have, the division that these are inputs and this is the output. You have characteristics of characteristics of a particular instance, and you try to build a structure, and that is called as unsupervised learning. Based on the structure, you do a lot of stuff, like either you cluster it or you segment it, or you can do a lot of stuff with that. Any questions about unsupervised learning?
Good, Asper.
You know, pretty clear. Last week when you presented the supervised learning, you also showed some Excel sheet, and I believe it was well received by the audience. And I also believe for unsupervised learning, you will practically show some examples in one or other way, I guess.
Correct. We will show practical examples too. Today, it was just an introduction of these topics. We are still in the supervised learning. We will be doing, we did linear regression last time, and today, hopefully we'll introduce logistic regression also. We are still in supervised learning. I'll definitely go to the Excel sheet and I'll show you how it works. When I come to unsupervised learning, I'll also look at practical examples and I'll use Excel sheet. I know that was helping the learning, so I'll use Excel sheet.
Thank you.
Okay, so this is the introduction I wanted to give about supervised learning and unsupervised learning. What I will do is I'll quickly go through what we learned last week, supervised learning, that is linear regression, before we jump into the exercise which we had shared last time. Oh, sorry. Before I go there, let me test with some of the examples. So there are 4 use cases which are given. You need to let me know whether it is supervised learning or unsupervised learning. OK, simple one, not very complex. OK, the first one, given an email label as spam or not spam, learn a spam filter. This is something which is which you have everywhere. Any email service provider has it. Google does it with the tabs. My Outlook does it with junk mail folder. So this is the algorithm which is being used. Sorry.
Supervised.
Yeah, this will be a supervised learning.
Because you know that based on some set of inputs, you know that your classification is going to be whether it's spam or not spam. So it is supervised learning. Yes, correct. OK, given a set of news articles found on the web, group them into set of articles about the same story.
Yeah, unsupervised.
Unsupervised.
Okay. Fine. Given a database of customer data, automatically discover market segments and group customers into different market segments. As I gave us an example, so you know what it is. OK.
Unsupervised.
Fine. OK. Given a data set of patients diagnosed as either having diabetes or not, learn to classify new patients as having diabetes or not.
Supervised.
Supervised.
Good. You guys are on top. I'll quickly revise linear regression. So what we saw was it's an example of supervised learning. What we are trying to do is the relationship that it is trying to establish, the model establishes between the set of inputs and output is a linear relationship. That's why it's called linear regression. It's the simplest of all, machine learning algorithms. So we took a simple example of y is equal to mx plus c. It could be more stuff too. If you have multivariate, multiple variables coming into play, it can be can be equal to m1 x1 plus m2 x2 and so on. So we took a simple example, y is equal to mx plus c. We saw how the line of best fit will be arrived at by trying to minimize the errors. We had something called as cost function, which we had derived. There's a formula. I'll move to Excel sheet soon. I'll talk about that there. And cost function is sum of the mean squared errors between the predicted and the actual value. With an attempt to minimize the cost function, what it does is it finds the model finds the line of best fit. OK, so for it to find the line of best fit, what it does is it uses one of the algorithms which could be used as gradient descent. And here what it does is it starts with a set of values for m and c. Here we have taken c to be 0, so we just If you look at the graph on the left hand side, m is the only value which is taken. Here it's denoted with theta 1. J is the cost function. It takes a value and computes the cost function, that is sum of mean squared errors, and it reduces the cost function by a particular value with a slope, and that's why it's called gradient descent. And when it finds the it reduces the value of theta 1 with a slope, so that's why it's called gradient descent, and finds the cost again. It does it again and again so that it finds a local minima, which will be the minimal possible cost function. That's how it
What
finalizes.
is the parameter here?
Sorry?
Parameter. It says parameter. What parameter we are talking about here?
So parameter is the value of m. See, m and c are parameters.
Okay.
Okay. So here, if you see, parameter is theta 1 here. I'll go to the Excel sheet. You'll understand it better. So what it does is it keeps moving to the lowest possible cost function value, and once it has finalized that, it says this is the theta 1 or m value which we'll have to take, and that's how the model is built. I'll explain that with the Excel sheet.
Yeah, and those who did not attend the first session, there is a video recording in the YouTube. You can go and look it up. That will help to kind of understand and follow through the second session. But anyway, yeah, it's great that Harsha is re-explaining it, but please go ahead, Harsha.
Okay, so we took a simple example where y is equal to x. That was the line which we had taken as data points. That is, the output is equal to the input. That is the simplest line which we had taken. What we tried doing was, see, initially it starts with, say, if you look at this equation, if you apply it in mx plus c, m is 1, c is 0. That is the line of best fit which we need to arrive at, because y is equal to x. That is what we have assumed. What the model does is say it starts with some m value, some arbitrary m value, and computes the cost function. Cost function is sum of it's a mean error square, mean of the squared error value. What is error is actually, if you apply y is equal to mx plus c, this is the value you get. If you, for this m, if you take m as 1.5, this is the value you get, but actually y is equal to 0. So what you do is you see the difference and then square the difference and take the mean value of all the error squared, you get cost function. So you take a value of m, c, and then look at the cost function for that. And then you reduce the m value with the gradient descent and then look at what the cost function will be. So we did this manually, and what we got was this is the graph which we got. So here, if you see, when m is equal to 1, okay, c we have assumed to be 0 because it's easier to explain with a two-dimensional graph. So when m is equal to 0, we get the minimal cost, which is when m is equal to 1, we get the minimal cost, which is 0. That's a minimum possible which you can get. So we know that for all the set, for all the m values of all the m values, we know that the best fit will be m is equal to 1. This will explain when m is equal to 1, we have assumed c to be 0. So y is equal to x. You get values which will match. This is what the algorithm does. We briefly saw the Python code for this, how it does. We use various Python libraries to get the line of best fit. Any questions, any doubts you have in this, please let me know.
Harsha, just to clarify, right? So we keep modifying this m value to actually reduce the cost, right?
Yes.
And reduce the cost, so the actual error becomes 0, and we get close to the y value. That's what linear regression. Okay.
That is what linear regression algorithm does. We don't do it. The algorithm does it. The model actually does this.
Yeah.
What we do is one point here. The error value need not reach 0 always. If you look at the slide here, see, it might reach a local minima, or it might reach a global minima. Sorry, when I say global, that could be local minimas like this, but it tries to reach a global minima, which is the lowest possible cost value. It need not be 0.
How do you calculate the next value of your theta?
So that is where the gradient. That is where the gradient descent comes in. So what it does is it takes the old parameter value. Say, for example, we took m to be 1.5, and then it takes a partial differential of the cost function with respect to the parameter. And there's another one.
So you must have at least 2 points before you get you can apply a partial differential.
No, you wouldn't need. What you're saying is because of the slope you're saying. That's why it's a partial differential. You're not taking the absolute differential, right?
Yeah, but partial differential, any partial differential requires there must be a difference between the old value and the new value for x and y, and that's how you would apply a dx by dy, right? Or dou x by dou y.
It is, yeah, dou x by dou y. That is what you do. In this case, it will
Yeah,
be
but you need at
dou
least
j
2
by
points.
theta.
Anyway, you still need, I think you still need 2 points to start with. So the first, estimate of theta and the second estimate of theta are required before you can even apply this.
Yes, that's a good point. I'll check when I forgot the code which I had written. I think what you're saying is right. We need to have the first two sets of thing for it to find the slope and then start working towards that. I'll check this and confirm.
Do you have somewhere in the slides the actual function from which you take derivatives?
Actually, see, you can do it in a Python code way. You can write the code for these computations. But what Python does is it offers libraries with which you don't have to be worried about any of these things. You'll have to just open the file and then you will get. You'll have to just use the right scikit learn and then you will get the regressor model built and it does everything on its own. You don't have to do anything at all.
Yeah, but it's good that we understand how these behind the scene it's actually working through your Excel sheet, right, Harsha?
Yes.
So it's a good thing to use the libraries, knowing what exactly it is doing behind the scene, right? That's one way of looking at it. The other way of looking at it is you can use the library without knowing what it is doing behind the scene, just worried about input and output, right? So that's another way of looking at it. As a developer, we can focus from both the directions, depending upon the priorities and the depth of knowledge one we need to understand. But from your point of view, training us on both the directions was really appreciated. Thanks a lot.
Okay.
Yeah, if learning what happens inside this fit methods, then there is no point to discuss partial gradients at all, partial derivatives at all. If we discuss them, then we should know the function that we take partial derivatives from, I guess.
So as Kadar mentioned, I'm just explaining how the model works because see, you can straight away know about this library and just call regressor, do that, fit the training data and do it. But it's better if you understand few things because when you use this foundation for building your machine learning knowledge, it will definitely help you.
Yeah.
That's the reason I'm conveying a bit of theory and then getting into these things.
I think it's actually very useful.
I mean, that bit of theory doesn't make sense if you do not write the function that you take derivatives from. Then the whole bit of theory doesn't make any sense. You should write the function you take derivatives from. Otherwise,
Okay.
Doesn't make sense, you know.
Okay, just
it
to
makes
answer.
sense from programming perspective, but not from explanatory perspective.
Okay, let me just answer this question. The derivative is taken with respect to the change in theta to the change in the slope of the theta.
Cost function, yeah.
Okay, so if the slope decreases, that's the direction you have to move along. If the slope increases, if the the differential is going up, the value of the differential is going up, then you're moving in the wrong direction for theta. If the differential is going down, then you're moving in the right direction for the next value of theta that you would take. Yeah, it's an iterative process. You go by changing the value of theta and then finding out what's the slope. Then change. If the slope is going up, you're wrong. If the slope is going down, you are moving in the right direction.
Yeah, that makes sense. Thank you.
Okay. Right. And so it depends to explain that. So see, it depends on where you are in this curve, where you start the initial value to be. If you're starting here, it will have a particular slope value. This negative and multiplying with partial differential takes care of that. If you're starting here, the slope value will be different. So what happens is if you have the value here, you're starting here, this formula actually reduces theta. to get to the local minima. Okay. So with that, I'll pause here. Saad, we'll have to move to the exercise.
Yeah, thanks, Harsha.
So just a question, Harsha. So the last time you explained the code and you also showed now, right? Is that exactly the exercise that we're going to go through now for linear regression? Just curious.
We'll be using those for sure. I'll allow Saad to explain that.
Okay, perfect. Thank you. Go ahead, Shah.
Sir, I have a question. Could you please go back to the slide deck?
Yeah.
So,
I stopped sharing if you want to open the slides again, Harsha.
Yeah.
So, if we just try to relate our formula y equal to mx plus c for this, equation, new parameter equal to, if you just go to your slide, please. How do you, is it, I mean, just want to check my understanding. Can we relate the old parameter value as m and learning rate as the error value? Is this how we
No.
did?
Actually, so when we say parameter, it is m, whether it's old value of m. Learning rate is one of the model inputs. Like you take the learning rate as alpha. You normally start at like 0.05 or something like that. So what you do is you take the, say for example here, okay, I'll explain with the Excel sheet itself. That will be better. So what we did here was we took the initial value of m to be 0.25. So in this case, since we know what the equation is, we know that we need to get m to 1. Okay, but when a model is trying to find it, wouldn't know. So what we do is we start with some arbitrary value, which is 0.25. Okay, so it takes 0.25. Okay, finds the cost function there. Okay, and then it goes to another value of m. So the formula which you saw here is actually the new value of m. In this case, in the example which we have taken, will be 0.5. How we arrive at, see here we took like in steps of 0.25. The model, what it will do is it will take a old value of m, that is 0.25, minus learning rate into partial differential. That is how it will take.
Okay, learning rate is an assumption value.
It's an assumed value. It's a constant.
Oh, got it. Thank you, sir.
Great, thanks, Harsha. Can you see my screen?
Make it a little bit bigger font, appreciated.
Okay. Is that better?
Yeah.
Okay, great. So in this exercise, what we're going to do is go over, you just have a data set and you want to start off doing some kind of analysis on it. Maybe you want to apply some kind of algorithm, right? So what's the first step that we would do? And what that is what's called EDA, Exploratory Data Analysis. So you're basically just going to go over the data set, get an understanding of it, see if there are any holes in the data sets, if there are any outliers, and if there are any problems that you might face later on when you actually apply a ML algorithm on it. So with these three commands, you'll have the Boston housing data set. I shared these commands in the last session as well. You don't have to follow along. If you do, that's great. It's more important that you follow this exercise, and you can always watch the video later to see. So let's go over the description of the Boston housing dataset first. So what the Boston housing dataset is provides us with these 14 variables, right? The median value of the home is going to be the the dependent variable. All of these other ones will be the dependent variable. So what we want to do is we want to see if we can use these values to predict the price of a home, right? So this is a data set. Again, these are the values that we will introduce. We will try to use them to find the value of a house. And we have 506 data points in this data set. The reason I'm using Spider for this analysis is because I want to show you guys the actual data set, right? Which looks something like this. So you have crime, you have all these other independent variables, and then you have the target, which is the price of each house. And this is obviously in tens of thousands. So now what do we do, right? So
and these data are already provided, and we have before we wanted to do anything.
Yeah, so the thing about the Boston housing data set is it's a very popular data set, right? It's used in a lot of different college courses and so forth. So a lot of these libraries actually provide this data set themselves, which you can use to test out different functionality in the library. In this case, the scikit-learn library provides this data set. You can get it through this command, Boston, basically load_Boston. So the first step is we want to see, okay, are there any duplicates in this data set that we have, right? So the first step would be to search for duplicates. When you are following this code, it's better to run it line by line, right? So here is a code which tells me the shape of this data set. It's basically the number of rows that we have and the columns, right? What I can do is I can use the drop duplicates command and then look at the shape of the data frame after I drop the duplicates. And we see over here that they're the same, which essentially means that there are no duplicates in this data. This is a very clean data set because you're getting it from a library. Usually when you have a real life data set, there are going to be issues with it. Second thing we want to check is there any value that we don't have, right? So a lot of times in real life scenarios, when you have a data set, you might have some values that you just don't know or you don't have, right? You can use isNull, which is again a pandas command, and then you can sum that. You can see that there is no null value in all of these variables that we're dealing with here. So another thing I can do is I can use a pre-built function. It's called describe. What describe is going to do is going to give me the essential sort of statistics regarding each variable. To use that, you just do the name of the data frame and then .describe. Here is what it looks like. So you have for each variable, you have the mean, you have the standard deviation, you have the minimum, the maximum, and the interquartile range. And all of that. So just looking at this data, you can understand what the different spreads are for each of these variables. And again, you can also see visually if you're missing something or if something just seems wrong, right? Now let's say this describe function, I want to visualize it. So then what we can do is we can use Matplotlib, which is a plotting library, to create subplots for each of these variables. The interesting thing about this is that it's going to tell us, okay, it's going to highlight what it considers outliers in the data, right? So you can see this is the interquartile range over here, and then you have values that are obviously exceeding it. So you can get a sense of the spread of the values using subplots. So again, all you're doing right now, you aren't changing the data, you're just getting an understanding of the numbers and the values that you're dealing with. So you can get an idea of the spread. So for example, with the RAD, you have a very wide spread. Let me see what this means. This is the, it's an index of accessibility to radial highways. Okay, now what I want to do is to see whether outliers exist in these variables or not, right? A lot of times you're dealing with data where you want to maybe get rid of the outliers. Sometimes maybe you don't want to get rid of the outliers, right? It depends from use case to use case. There are many different ways of finding outliers. One method would be using the interquartile range and trying to find the outliers. So the The method for that is you take the interquartile range, you multiply that by 1.5, and then you check the distance of a value and the distance of the product of 1.5 and the interquartile range. Now, this works well if the data is in a normal distribution, right? The closer it is to a normal distribution, yes.
It's possible that some of, maybe most of them, right? But some of them may not know what is outliers from the point of view of statistics. Maybe you can a little bit explain that.
Yeah, so an outlier is any value within a series that doesn't fit within some kind of, reasonable range. So, for example, if you have a group of kindergarten kids and you have their heights, right? Those heights are going to vary, but they're going to vary within some kind of reasonable range. Any value outside of it, for example, if you have a child who is 7 foot in kindergarten, that's that's an outlier, right? So, and that kind of value will mess up your data. So we need to have a method to detect outliers in all of our data, because if we have data with a lot of outliers, whatever analysis we're going to do on it later on, it's going to mess up that value. So using this interquartile method, I got the percentage of outliers in each of the columns, right? Now, I mentioned before that this only works when you have data that is in some kind of normal distribution, right? This variable, I'm getting 100% outlier, but the reason I'm getting this is because this variable is actually a categorical variable. And what is a categorical variable? It's like a 1 or a 0, or it could be a bin as well. It's like a category. Because it's a 1 or a 0, I don't need to worry about that as an outlier, right? So now the question is, what do I do with this information? Do I get rid of the outliers? Do I consider them in my analysis? Well, in this case, we're only dealing with 506 data points, right? So if I start taking out all the outliers, we're going to reduce the size of the data frame by a lot. We'll be left with a few hundred data points, and any analysis that we'll do won't make much sense. But this is something to keep in mind as we continue our analysis. Maybe if I get rid of one of these variables, I'll have a better fit of my linear regression or whatever model that I use. So it's just something to know and keep in mind. Now, another thing I want to see in this data is there a relationship between crime and the this variable, right? The proportion of what is it, residential land zone for whatever this variable is, right? I want to see if there is a relationship between each of these pairs, and I'll tell you in a bit why that's important. And I'm going to do that visually. So what this is a heat map. We have all the variables on the X and the Y. So you can see, and what this does is it does a pairwise correlation of the values. So obviously, because it's comparing crime and okay, 1 second, we're on this. Now, what is this telling me? So it's telling me that obviously these are going to be ones because it's comparing crime and crime. So obviously that's going to be 1, but the other pairs are what we're interested in, right? What we don't want in a linear regression is a very high correlation between 2 independent variables, because if that exists, so for example 0.9, that's something that's very high, and it could be high in either direction. That's a sign of something called multi-collinearity, which means that these 2 variables are very closely linked to each other. And again, going back to what Harsha said, we're looking at independent variables. If there's a lot of correlation between 2 variables, what that tells us is that these two might not be really independent. So we really need to look at, okay, are these actually independent? If they're not independent, then we have to make a decision on whether or not we want to include them in our analysis. Let's just look at what this 0.91 value is, right? It's between RAD and it's between taxes. So what these values are, it's an index of accessibility to highways and tax, the property tax that you have to pay. Now this, just looking at it, you can say that, okay, there has to be some relationship here, because what you would have is, if you have a city, it's going to be closer to a highway, and because you're living in a city, you might have to pay more taxes than if you were living in a rural area. So now, you know, as a data scientist, you would have to make a decision here. Okay, should I get rid of this value? Should I make another composite value that includes both of them? Or what should I do? So let's look at another way to illustrate these correlations between two values.
Chad, sorry, could you explain what is a heat map?
Yeah, sure. So this heat map is based on correlation. Over here we have ZN and we have crime. So all it's telling you is what's the correlation between ZN and crime. That's it, which is in this case minus 0.2. That's all. And you have that for all of the possible pairs in these variables that we're dealing with.
Could this get color coded in a way that you know, high correlation is red or hot, something like that, or is it always just a random coloring?
Oh no, it's not random. So the way this works is you're dealing with built-in libraries, right? Okay. So if you look at this function here, which we plot.show, for example, you can change all the specifics about how this is done. What you'll have to do is you'll have to go in the documentation for this function, and it's going to have a huge list of basically all the ways you can change almost anything about this. So yeah, you're right. It would be better if it's color coded in a way where you look at the absolute value, right? And that's something that I can do right now, but I know that there's probably a way that you can do it.
Okay, thanks.
But in a high level, heat map is basically showing the relationship between two variables in the form of positives and negatives, right? If I look at in the right hand side, you have 0.9 and then below probably in negative, right? So the more towards positive is good and more towards negative is bad, or vice versa, depending upon the case, is how the heat map should be read, is it?
No, so it's you have to look at the absolute value. If the absolute value is too high, that means that these two are correlated. They could be inversely correlated or they could be positively correlated. But the correlation is what you should be worried about if you're doing a regression analysis, because that might mess with your results.
Okay, got it.
Now let's say I want to see these numbers plotted, right? So I can use the Seaborn library, and again, all I have to do is insert this data. It's going to do everything itself. This command might take some time, so I'll just show you the resulting boxes. So this is the same heat map. It's just that it's actually plotting the values now. So let me just look at one example here. So we have taxes and so here. Here is an example of that correlation that we're talking about. Again, these are values plotted against each other. So the same pairs that you have over here, these data points are the same values. They're just plotted against each other. So you can see when this says 0.91, what does that mean, right? How does that look? So another way you can visually see them plotted here. And again, this is all, you don't have to, you just have to put this in the function and it's going to give you this visual. Now, the question
Just
is like, yeah.
yeah, just to give a better perspective of what this is about, we saw two things. One was the tax versus index of proximity to highways. So
Yes.
when you have a high correlation between them, what we're trying to say here, I think, is that we need not consider both the variables in in your analysis or in your machine learning. You may actually drop one of them because the correlation is so high.
Exactly. So if you don't drop them, what's going to happen is any coefficient you get that gauges the change in the price of a house based on a change in taxation, that won't be accurate, right? So to have an accurate change in price, you will need both a change in tax and a change in the radius to the highways. So ideally, what we would want to do is either have get rid of one of these or create some kind of composite variable, which includes both of them. Now, this is a very inefficient way of dealing with this kind of issue, right? So how would someone do this same thing in an automated way? One thing that we do usually is we look at all the possible ways or all the different possible combinations of variables. We then do a regression for each of those possible ways. And we program the script in a way where the best fit is the one that we end up choosing. That's not something I'm going to show right now, but again, we need to find a way where we can figure out what to do with the outliers, figure out what to do with the presence of multi-collinearity that I just showed you. So as we go forward, we'll have to come up with ways that we can deal with both of these problems, right? But this part is just looking at how we can explore, discover that these problems exist in the data set. And again, this code I'll share it with everyone so you can actually replicate this on your end as well.
You're going to put it in the GitHub, right?
Yeah, I'll put it in the GitHub.
And again, those who do not have a GitHub account with Testoper, send your GitHub ID. We will also add you into the GitHub account, right? So you can get access to all the codes that's been done and all from there.
Okay, we have a few minutes left. Harsha, do you want to give a very brief introduction to logistic regression?
Hey, before Harsha, sorry, I'm asking too many questions here. So the job of understand, okay, so let's say, for example, in Testoper community, we are working on a project which is to kind of get access to the labor data to help people to choose the right career path, right? This is something that we are looking at. So now you have the data sets from available, and you need to understand the data set, how it has been available. So is that a data scientist job or AI software engineer job? I'm just curious.
No, I mean, if you're a data analyst as well, you would do the same thing, right?
Yeah.
There are a lot of roles here that there is what you actually do is very similar. It's more about if you are applying a specific kind of algorithm, right? Then you might want someone who has experience in applying that kind of algorithm. Maybe it's computer vision, for example. But this stuff, linear regression, logistic regression, this is a lot more basic. So anyone who's a data analyst, data scientist would be great at handling it, I think.
Okay, got it.
And this is all, like this right now is just basic statistics, right? We haven't even gone into the machine learning part yet.
Yeah, that's looking forward to. And all the presentations that you guys have been presenting is again posted in the Teams, right?
Yes, Kadir.
Did you send please send the presentation to Mickey so he can post it in the Codeathon channel?
Yeah, there was an overlap between Harsha's presentation and my presentation. Since Harsha's is more extensive, I think it's better just for that to be there. So his overview of supervised and unsupervised is more extensive than what was in my presentation.
Yeah. That's okay. Just put both the presentations, for the people to kind of, use them. Yeah, I already see it. It is in the Teams. That's good. Thanks. Go ahead.
Yeah, but the GitHub link and where we can download some of this code that we are discussing would be good to include.
So we share those files too. Say, for example, last week when we did linear regression, the code which I had shown, it is shared.
Thank you.
Yeah.
It's in the Teams.
Where is it shared?
Yeah,
Where is it shared?
Yeah, let me check on this for everyone to actually see. I'm sharing this quickly. So in the Teams, right, you are mentioning. So in the Teams, Codeathon and files. So we are going through intelligent automation track, IA, and okay, this one is this one right here. Is this what you're talking about?
The first file is the Python file.
Okay, okay. And you should not put it here, right? You should put it in the GitHub. You have to create the same way the structure is there for GitHub. You should create it in the GitHub, Testoper GitHub, and you have to put it there with the dates, the exercise files in the GitHub, not in the Teams, just to clarify, okay?
Okay.
And those who do not have, like I mentioned, GitHub access for Testoper GitHub access, please share it. I think it's whether I have access, right? So this is github.com Testoper. I believe this is the one, right? So we should probably be having here. Is it Testoper or Testoper community? I don't know. I think it's community.
Rather, it is community. Testoper community. It is there in the same page. It is there. If you go bottom there.
Oh yeah. Okay. So Testoper is a username. Okay. So in this there is an IA track. Okay. And here in IA track, we should probably have this code. There is an exercise here. There's a previous one, cloud training, right? So maybe here what you can do is exercise, and then you can create here Python with AI, and then you can put your stuff here.
Okay, Kadir.
Just there is a structure Mickey can help you with, but I wanted to show here to make sure that everyone understands. And if you have a GitHub ID, just request, we will add you into this so you get access to this whole thing. Right? Yeah. Any other questions, please?
Yeah. How do I join this Teams that you say I should log off and then go and join some your company in Teams instead of my what do I use after I log off from the
When you
Teams?
log out, when you're trying to log in into any software, it will ask you the username and password, right? So
yes. How do I get this username and password?
Yeah, once you are added into the Teams, like for example, today we have, if you go here, we have 204 people, right? So now what we have done is we add them into this, like add member. So when we add them into a member, you get an email automatically. So you have to click, once you get the email, you click that email, it will take you to a login screen. Just put your login, the email ID, and then say forgot password and reset the password. Then the next time when you log out and log in, you can use that login and password to join the Teams.
Okay, got it. Thank you.
Perfect.
And Gregory, you should have received that email because I've added Gregory and Madhav both into Teams. So you should have received emails from us.
Yeah. Any other questions from the logistics point of view? Because this is important, right? I want to make sure that you guys are able to log in. And I also wanted to make sure you understand, right? This most of you know. For those who do not know, this Testoper is a non-profit community, right? It's run by all of us together. So today, Shad and Harsha is giving sessions. You guys can give sessions. We are building some software for the community to help. So you can join in building that software, and get an experience certificate. So it's run by the community people, for the community people, and it's a non-profit organization. We don't run this for profit organization. We depend on you guys to help us with donations, company sponsorship, whatever, to spend on the tools that we use to deliver. But that's what Testoper is all about. Just want to make sure that you guys understand. So Harsha, 1 minute left. What do you want to do?
I wouldn't start logistic regression with 1 minute left, Kadir. So I'll need at least 15 minutes. So I think we should move it to next session.
Right?
And there is a question we can look at it.
Yes.
The usage of this in practice. Can you give some example? That's from Turhal Hassan. Can you explain what you wanted to know?
Turhal, can you hear us? Maybe, I don't know. I believe you guys are providing practical examples, so good. I think when you were presenting, some of them may not have joined the previous sessions, right? So maybe they were lost. For those who did not attend the previous session, please go and look at the YouTube. I believe someone was asking where in the YouTube is the data being provided to that person. I'm not sure. For those who do not know, it's pretty simple, right? Go to youtube.com. youtube.com and can you see my screen?
Yes, Kadir.
So just go to youtube.com and then put Testoper. It's pretty straightforward. And then there is a Testoper community. And if you go there, you would actually see all the videos that we have are posted here, right? So you can go to the playlist, and in the playlist, you can actually see here IA track. This is a Saturday track. You can click this. Sorry. All right. So if you actually see this, you can go to the YouTube and there's multiple playlists. The Saturday session is an IA track. You can click the view playlist, and then in this playlist you can actually see all the sessions that we have been doing. So we started with cloud fundamentals, we finished Kubernetes, and we finished with Python session 1, and today's session also will be posted here. So if you wanted to go back and learn, it's all available here, right? Depending upon your interest. There's multiple tracks that we do and so on. Again, it's the same thing, right? If you wanted to know about our programs, what we are planning and ending this year and what's going to come next year, we'll normally post it. Same thing, go to the Eventbrite and search for Testoper, you would actually see it. And then you can register them, right? The upcoming programs. And normally on December, we more or less post all the programs that we're going to do for the next year. Okay.
Yeah, so I registered in Eventbrite. So would I get access to Teams now, or do I have to follow any further process?
Eventbrite allows you to click the link and join our session, right? But it does not allow you to become a user of the Teams. So after you join the session, we normally tell in the session for those people who wants to join the Teams, send us the email, because we don't want, see, there's a privacy concern also, right? We don't want it to kind of add everyone into this Teams. We want to add only those people who are joining our sessions into the Teams. If you put this link, somebody was asking in the Codeathon group, can you send the link for the meeting, right? So in the Codeathon group and in the Teams, we can share, because we have only people who joined us or brought into these community, not to the general public. Otherwise, you will see a lot of spams and many things will come in. So the long story short to answer, so the Eventbrite will allow you to get to the link and join the session. But during the session, we basically tell you to join our WhatsApp group and join our Microsoft Teams, and we help you to join in both the things during the session. Hopefully it answered the question.
Yeah, for some reason I'm new to this Teams and I couldn't join your. Should I have to search for Testoper in Teams? Do I have that option, sir?
No, Teams is like a Slack channel, right? Teams is a private. It's not a social media like Facebook, right? Where it's not like Eventbrite, where you can go to Eventbrite and search for Testoper, and Meetup, you can search for Testoper. So those are the social media tools, right? But this is a collaboration tool. Social media tools public for everyone, like Eventbrite, all those things are. This is a collaboration tool which is for the closed group of people. And so Teams, what we have here is for the collaboration tool for the closed group of people within the Testoper community. So those who join our programs, we request them to join the Teams, but you can't get this publicly, because this is not a social media public tool. Okay.
Okay.
Same as Slack, right? You can't just go and join any Slack you want, right? You need to really you have to be invited to join into the Slack. Likewise, you have to be invited to join into the community of Microsoft Teams. And we normally invite only those who attend our programs. Hopefully it answered the question.
Yes, sir. I would like to get that invite if that is okay.
In that case, you have to send your personal email ID. in the chat window, right? So we can add you. We can add you, then you, yeah.
Got you. Thanks for clarification.
So everything is in the chat. You should actually go back after the session, go up. There's a WhatsApp link in the chat.
And
I couldn't find.
You know, there's a lot of people are sending email.
I followed the steps and created the password.
Sorry, was there any other question?
Yeah, I followed the steps and created the password for the email that I provided in the chat, and opened the team, but I'm not sure that I actually joined your organization.
If you join the teams, you should see this Testoper community and this channel. You won't see all the channels, or at least you should see Testoper community channels. If you see that in the left, that means you are in our team.
No, I did not see it.
So maybe you have not logged in correctly. So what you can do is, you are in WhatsApp, you can ask for help. Someone from our volunteer from our team will get you into the call and they will help you out. Okay.
Okay, thank you.
Yeah. Anyone in our team will join, right? Everyone, whoever is in the call is also volunteer. If someone knows how to do it, they can actually come in and help you how to do it. Yeah, just ask help in the WhatsApp. You would be provided. Any other questions on logistics, please? If not, you know, Shad and Harsha, awesome, and one more wonderful session, top notch. We'll continue this next week, same time at 10:30. Everyone are invited to join, and those who have missed the previous sessions, please go and learn from the recordings and join. All right, you guys take care and have a great, wonderful week.
Hey, sorry to pull you back, but you were saying that we will have some sessions more like a practice on what was taught, more like a group study kind of a thing. So are you planning for anything for this AI code as well, sir?
Yeah, so I first join in the Microsoft Teams, right? And you can ask these questions in the Microsoft Teams. You know, once you join, you will have access to the study groups, and you can ask. See, study groups is not started by it started by the people, right? So like for example, we have 3 or 4 groups of people who have come together and who have been studying together few things like Microsoft Cloud certification, and they went to certification. So it's like, think about it. Like when we were young, we used to, go to our friend's house and sit together and study, right? So you have to make friends. Once you are in a community, you have to make friends, get together, and then form your own study group and start studying. So that's one way of doing it. The other way of doing it is sometimes our programs team, the community volunteer team and programs, they come up with some plan to start a new study group, right? So that's another way of doing it. So the both ways happens. Okay, so it's totally depends on how you wanted to take it forward once you are inside the community. Okay.
Yeah, makes sense. Thank you so much.
Perfect. All right, guys, weather is good. Enjoy this weather today. Go out, whatever, and let's talk next week Saturday for those who are attending this session, and next week Wednesday for those who are attending the test automation session. I'll talk to you guys soon. Bye-bye.
Bye.
Bye, everyone.
Thank you.
Thanks.
Bye.
Thanks.
Thank you.
Thank you.